Hi, in this video I'm going to show you my spooky, laughing Halloween skull. It's a 3D printed skull that's motion activated and has a servo in the jaw. In this video specifically I'll be covering the history of this project, the changes I've made, and the circuitry behind the control. And in future videos I'll be covering the 3D printed aspect of it and the assembly of the skull. So, a bit of history. In late 2016 I was just getting used to my 3D printer, which I'd got sort of the January-February time. Had a lot of trouble until March, and so I was brand new to 3D printing, having a lot of trouble, but I was just about getting sorted with 3D printing, and I wanted to challenge myself. And while we haven't had much of a trick-or-treat culture around here recently, I really fancied making a 3D printed Halloween decoration, preferably one that might scare any trick-or-treaters. So my thought was a motion-activated laughing skull. I was pretty sure I knew how to do that, get a little servo motor, get the jaw going up and down, get some LEDs for the eyes, use a PIR motion sensor to get the actual triggering happening. I set about looking for an open or Creative Commons skull. I was pretty sure there'd be a skull that I can adapt to taking a motor, and to both my delight and my disappointment I discovered that someone had already made a skull from an open Creative Commons static skull that took a servo and had room for some LED eyes. So that was this file by Death Metal, Robot Skull Like Jeff off Craig Ferguson. It's Creative Commons, share alike and attribution, and that itself was a remix of several other projects. So I was delighted on the one hand because I wasn't going to have to fiddle around with modifying the skull, but on the other hand I was disappointed because I was pretty sure that was going to be the biggest part of the project. However, I wanted to take it a little bit further, so I wanted to make it as easy to print as possible. I'm also big on trying to save time with prints while also keeping quality as high as possible. So I wanted as much empty space as possible, both to try and fit electronics in it and also to try and reduce print time. I set about making some modifications. If you imagine the skull lying flat, I chopped the top off around about here. So the idea was that the top would print separately, and then I could turn the skull upside down, thus reducing the amount of supports required, because obviously this would all need supporting, the teeth would need supporting, all this would need supporting, and I just felt like printing it upside down. Well, there's a little bit there maybe, a little bit there, not a huge amount needs support, and anything else for the cavity that I was going to create, everything else that needed support would probably be okay with less support because it's an internal surface, you're not really going to see it. My next problem after the modifications was working out how to do the electronics, and I looked previously at doing some audio projects with Arduino, and the audio boards that could play MP3, WAV files, etc. They all seemed really expensive, they're sort of £25 plus. And I was thinking, well, I've got Raspberry Pis, some of which are designed or that I've designated for electronics projects. And I thought, well, the Raspberry Pi can play audio, but I'm not sure it's going to be able to support running a servo. I know people have done it, but I didn't feel comfortable doing it because the jaw, while it's not hugely heavy, if it gets stuck it's going to draw a lot of current and potentially blow up the Raspberry Pi. Raspberry Pi is still more expensive to replace than the Arduino, even though it's still relatively cheap compared to the audio boards. But the Arduinos are relatively cheap to replace even then. So I thought what I'd do is I'd run the electronics from the Arduino, and then I'd run the audio and the triggering from the Raspberry Pi. And so I'm going to show you now how I did this. So I had two ideas for this. I had read somewhere that the Raspberry Pi could communicate with the Arduino safely by using I2C. I should preface this by saying that the Arduino outputs 5 volt signals and the Raspberry Pi can only accept 3 volt signals. So obviously if you try and send a 5 volt signal to the Raspberry Pi, you can potentially end up damaging it. So I went looking to see how you could do I2C between the Raspberry Pi and the Arduino with minimal in-between hardware. So I could have used level shifters, but again that's another bit of hardware that goes in the middle, and they're not necessarily the cheapest things. They're not expensive, but I was trying to keep the project as low cost and compact as possible. So I found this article by Oscar Liang, which you can read. It's very good, helped me a lot. And basically the idea is that if the Raspberry Pi is the I2C master, then it controls the signal levels between the Arduino and the Raspberry Pi, and the Arduino can basically send data and receive data at the 3.3 volts that the Raspberry Pi can send and receive. So I went with this as my first idea, which you can see here. The red wires are the setup for the I2C version. The green wires are common to both systems, and then the blue wires are how I ended up doing it. And these ones should just be green as well. The idea was, in my first iteration, the Raspberry Pi and Arduino would be connected by I2C. The Arduino would then control the servo and the LEDs. And then the Raspberry Pi, when it got a signal from the PIR, it would spawn a new process, play the audio, and tell the Arduino to run the servo and turn the LEDs on. I should also mention that the PIR, while it runs off 5 volts, it outputs the 3.3 volt signal, so it was perfectly fine going into the Raspberry Pi. The I2C version did work, but it was a little bit intermittent, it was a little bit glitchy, there were delay issues, and it didn't work brilliantly. I got a bit fed up with that, and I thought, well, the only other option is to use a level shifter. And then I thought, well, if I'm going to do it this way, then the Arduino can control all of the electronics, and the only thing the Raspberry Pi needs to do is play an audio file if it gets a signal. So I set the PIR onto the Arduino, I set the servo on the Arduino, and I set the LEDs on the Arduino. The LEDs aren't shown, but it's relatively simple. You can see them in a future version that I'm going to show you later. And I thought, well, it's only the one signal. I only need to get it from 5 volts to 3.3 volts. So I decided, well, what would happen if I used a voltage divider, which is basically 2 resistors in series. You can do the calculations, and the voltage in the middle of the 2 resistors is what you send to the Raspberry Pi. So I can't remember exactly what the values were. It should be fairly easy to look up. Don't go based on these resistors, these are just generic Fritzing resistors at 220 ohms. If you're going to do it, look it up, you'll find the calculation. This worked really well, and it's basically how I kept the project going until I sort of dismantled it sort of mid-November. But I was never quite happy with it because it's quite cumbersome, it takes a lot of space in a box. You've got 2 boards that are about the size of a credit card, a little bit smaller in the case of the Arduino. It was just really clunky. It worked, and it was definitely cheaper at the time than buying one of those audio boards, but I just wanted to try something else if I was going to bring the skull out again. Cut to 2018, and I wanted to try it again. So I had a look. This time I was determined to try and, if I could, get it working just from an Arduino or an Arduino-like board. So I set about looking for MP3 player boards and or Arduino compatible boards that could do audio directly. And I just happened to stumble across the DF Robo DF Player Mini, which on Amazon you can get for about £1 if you're willing to wait for it to come from China. Otherwise, I found you can get 2 for about £8 to £9, which is a lot more expensive, but it's still a lot cheaper than the £25 that I was looking at for the audio boards before, and a lot cheaper than a Raspberry Pi. I did actually have one possible further idea, which was to use a Raspberry Pi Zero, but the Raspberry Pi Zero doesn't really have audio outputs unless you use the HDMI port, or unless you add some additional circuitry to build back in the audio outputs that this has lost from its bigger brothers. So I was hoping not to have to do that if I could, because again, we end up in the same situation of having to use level shifters, I2C. So I was really pleased when I found the DF player. I tried it on an Arduino Uno and it worked fairly well. It would play the audio, it would run the servos, and it would run the LEDs, and that's basically all I needed. I still had this idea of, if I can, I'd like to be able to fit the electronics in the head, and then possibly just have the box underneath for the power supply. So I really wanted to try and squish that down onto an Arduino Nano if I could. So I took exactly the same circuitry and I put that onto the Arduino Nano, and I had a little bit of trouble. It didn't work as well on the Nano as it did on the Uno, and I spent ages trying to solve it. I'd fix one thing and something else would break, so like the DF player would sort of jitter, and I'd fix that, and then there'd be a lot of noise, and I'd fix that and the jitter would come back. Or suddenly the server would misbehave. After a lot of fussing and looking online, I eventually came up with a solution that I think works. This is the circuit that I've come up with. So this is the DF Player Mini, this is the Arduino Nano. The Arduino Nano is basically an Uno, but it's been squished down into a finger-sized board. A lot of this circuit is sort of working around the issues that I had. Official wiki says to put a 1K resistor between the RX on the UART serial input, a DF Player Mini, and the TX line on the Arduino. So I did that, didn't help that much. Someone else suggested putting a 1K resistor on both the RX and the TX. So I did that and that didn't help much. Someone else said, well, put a 100 microfarad capacitor between the VCC and the ground on the DF player. And that didn't work particularly well. And finally, someone said, well, the DF player takes between 3.2 volts and 5 volts maximum. So what most people have been doing is they put the DF player directly onto the 5 volt line of the Nano, and that can cause issues. So I was fiddling around with all these combinations of things, and then an additional variable is that you can use either a standard less than 3 watt speaker unamplified, and that was working okay. It was a little bit muted, it didn't have a lot of depth to it, and on the Raspberry Pi version what I had used is this little X Mini amplified speaker. It has its own battery which lasts a surprisingly long time. I left it on overnight and I thought I was going to have to charge it before I could use it again. It stayed running and it's still going even now. It has a little 3.5 jack on a tiny little wire. You can open it up for a little bit more boosty boost on the base, and it's just a really nice little speaker. They don't make it anymore, but Amazon has a lot of similar little speakers. So that is a variable. You can use either of these, and I shall sort of explain how now. The other thing is, this is a 3-watt speaker, and technically the DF player should be used with less than 3 watts, but I couldn't find a speaker anywhere near the same sort of size. This is a much bigger speaker. This is 2 watts. So it doesn't necessarily look much bigger, but it's quite a bit bigger. And also it's bigger in this dimension. This one should definitely fit in the top of the skull. If you want to do that, you don't have to do that. I was kind of toying with the idea of doing that. This one definitely won't. This one also came with a funny little JST of some sort, and I couldn't find the equivalent other side. And the wire's so short, and they've waxed over it and stuff. I didn't particularly want to disconnect this if I could avoid it. So I'm probably going to use that for another project. I don't know what. I was having trouble. It worked fine using the unamplified speaker, but when I looked at possibly using the X Mini, I thought, well, the DF player has these 2 ports here, or these 2 pins, and they are for a digital analog converter, which is meant to go to an amplifier. And I thought, well, this is an amplified speaker, so surely that must go to the DAC connections. And it worked, but it was exceedingly noisy. The slightest movement of a wire would hiss and crackle and pop like an old record needle. And I thought, well, look, this is silly, it's not really working. I'll just try it, cautiously and tentatively, I'll try it on the speaker outputs, and it worked fine. So then I was fiddling around, and I discovered that through a combination of trial and error, the diode works perfectly for the X Mini. However, the diode causes problems for the DF player when it's trying to output to the 3-watt, and I suspect that might be because the 3-watt draws too much current for the DF player and it keeps turning itself off. However, I wasn't able to test it with less than that, but the DF player was rock solid without the diode when using this speaker. However, both of them benefited from having the capacitor here. So this is, in my project I've used a 470 microfarad capacitor just because that's all I had lying around. I either had 10 or I had 470, and I thought, well, a little bit higher is probably better. I then went for 10k resistors on the TX and RX. It might be a bit overkill. You might find a little bit, you might want to try lower ones like the 1k recommended, but I think personally the 10ks were a little bit better, and I do think they were a little bit better again than the not having any resistors either. Final note is that the UART connection on the DF player can either be done through software serial or hardware serial. Now the Nano, as I understand it, only has the one hardware serial port, and that is these 2 pins here, D1 and D0, but these are also used for USB serial debugging. So if you want to send print commands to your PC so that you can see what's happening on your debug, you can't do that if you're using the hardware serial for the DF player. But I actually found that there's less noise if you use the software serial and use like a third-party library like Neo SW serial, which has better interrupts and timing and whatnot than the standard software serial. You get less noise and interference, and you don't have to unplug the DF player to reprogram your Arduino. So I actually ended up just going with the software serial because it worked. I thought I I thought because of issues with PWM noise and servo noise that I was going to have to go for the hardware serial, but adding the capacitor and the 10K and using the X Mini solved most of those problems. Final thing to say is that the LEDs I've put on pins 3 and 5 because they're PWM, and I wanted the LEDs to jump on full brightness, and then when it finishes laughing it sort of fades out like it's going back to sleep, because I thought that was just a little bit more eerie than it just going on and then off. But the PWM signals to start with were causing a lot more interference on the DF player. So the capacitor definitely helped with that, and the same with servo noise. The only thing that I'm now struggling with over which I'm not sure how to fix, but it's not a huge issue. The servo occasionally just jitters when the Arduino turns on, and it doesn't stop until it does its first laugh. So it's sort of in your interest to just trigger a laugh as soon as you can. If this project proves popular and lots of people want to make it, I am considering making a little PCB that would be for sale and or for download if you want to try and make your own, I guess. That should hopefully be a little bit more compact than this half breadboard, because I don't think you can get it much more compact, but it would be nice to get it more compact just so that you can sort of try and squeeze it into the skull if you want to. Final thing to say is if you have trouble running it at 5 volts, try a IN4001 diode between the VCC and between the 5 volt on the Arduino and the VCC on the DF player. As I said, I found it caused problems with the unamplified speaker, but didn't cause issues with the amplified speaker. So it might be worth, if you're going to use the amplified speaker, maybe just put it in there anyway, just to keep the longevity of the DF player, keep it protected. But yeah, it all works fairly well. I found that while it can play WAV files, because it's designed to play MP3s, it plays them better. I found my laughing track originally was very much, it was a wave, and there was always a very loud click pop sort of noise at the end of the track, and as soon as I converted that to an MP3, that disappeared. So I think that's all there is to say about the circuitry. It's fairly simple in the end. I'd recommend using the capacitor. Someone said 100 microfarad, but as I said, I only had 470, so that's what I've used. LEDs are fairly simple, they just go to the PWM. If you don't want it to fade out, you can use any of the non-PWM pins. The PIR just works as it is, outputs 3.3 volt signal, which is high enough for the Arduino to trigger, runs off 5 volts. I've used D11 and D10 for the software serial. I believe any PWM capable pair of pins, so 7 and 6 should do. And yeah, it works surprisingly well now, apart from the little glitches with the servo, which I think is more of an Arduino servo library issue. So maybe, I don't know, I've looked at how to fix it and I can't see a way. I'm going to do a couple more videos, I think. One on the modifications that I've made to the original files, how to print them, so I'll set them up in Cura, stuff like that, but I'm not going to show the print happening because I don't need a second skull. And while I've made some modifications, I'm fairly happy to say that they should print as they are, because I've made similar modifications elsewhere on other projects that have worked fine. But if you want to test it, or if you're you don't want to test it because you feel like you shouldn't be the guinea pig, that's fine. I can either upload the original files that work but may need gluing. I've also made some other modifications that just are minimal compared to what I've done in the previous project, so they should print even better. There isn't time in that video. I'll do another video on the assembly and finalising of the skull and sort of putting the electronics all together. So yeah, I think that's all I have for this video. Thanks for watching. I hope you enjoyed it. Apologies if it was a little bit rambly. One more thing to say, there is a long blog post that is basically this video plus the other two, all on one page. It's very long, but if you want to make this quickly before Halloween, you may just have time. If you're very good at printing or you've got multiple printers, you might be able to just squeeze it out in time. So I did one big blog post in the hopes that anyone that wants to do it as a last minute thing will have all the information they need in one place, and they don't have to go through multiple blog posts to find the relevant information. I would have liked to have done that with the videos as well, but as it is, this one's been quite long. The other ones will probably be a little bit shorter, but hopefully, I think they need to be separate videos, and if you need the information in one place, go to the blog post. So yeah, thanks for watching, and I'll see you again soon with the other videos.